Hey everyone, I hope you're all doing well. Today, the video's topic is going to be about quadratics, and quadratics is one of the biggest units you will probably cover in grade 10 math. You might see it again afterwards, but then you do other types of functions, right? And if you don't know what a function is, right, functions are just other sets of equations that give you different graphs also, right? It has an input and an output. If you didn't know, you did linear stuff in grade 9, and a linear equation is considered a function still. Um, Function is just like another way of saying it. Function is equivalent to saying, for example, let me quickly write it. Function is equivalent to, oh my, function is equivalent to y, right? So that's like the kind of notation for a function. It's called, you can say it as f of x, um, but this f of x also means y, right? So when you see y equals mx plus b, that you can also say f of x equals mx plus b. You don't usually say, you usually just say y equals mx plus b for these, but that's pretty much it. Again, today you will be learning about quadratics. You don't need to worry about the f of x stuff now. Um, it's just a notation thing. But today we'll be discussing about quadratics. So again, in grade 9, you guys did a lot of linear things, right? And basically, to compare it to linear, and what really just defines a quadratic is that a quadratic is to the power of 2, right? That's really the main difference between a linear and a quadratic, because as you know, a linear, right, is just y equals mx plus b, and is technically to the power of 1, right? And it has a slope. But now we'll be doing more things with more equations that have the degree of 2, the power of 2, and that is a quadratic. Um, as you know, your skeleton type of like formula, you could say, for a linear equation is y equals mx plus b. But for a quadratic, the equation is is very different. You The skeletal equation is ax squared plus bx plus c, and a, b, and c all have integer values. They all have real values, and those values can vary, obviously. And your base graph for a quadratic is y equals x squared, is right down here. And I'll talk a little bit about this graph, y equals x squared. It's very similar concept to linear things, and very similar concepts to things you will learn in the future. Um, Basically, to get this graph right here, right? You're going to be dealing with a lot of curves, right? Um, Parabolic shapes. This is a parabola. Oh my, I don't even know if I'm spelling it right. Parabola. Pretty sure. Yeah. And basically, you're gonna go from doing straight lines to be doing like curved U-shaped graphs, how to graph them. But in today's video, we're just gonna say what is a quadratic, right? Next video, we'll talk more about how to graph a quadratic and how to find key characteristics of a quadratic. Um, if we look here at this t-chart kind of type of thing, you're gonna see I inputted values into this equation right here, right? I inputted values into this equation right here, right? And I put their outputs, and that's how I graphed this. Though these red dots right here are the coordinates that I have here, right? It's not to scale, but it's roughly about how it would look. And don't worry about this. This may look a little intimidating now, this skeletal formula, ax squared plus bx plus c. That may look a little intimidating now, but once you go more in depth about characteristics and how to graph, trust me, it's very simple. Uh, and also, parabolas, right? Your quadratic equations, this right now, like I said, there can be an A, B, and C value. Those A, B, and C values determine the transformations, and I'll write it down, transformations, oh my, transformations of the parabola, okay? So let me see if I can actually highlight. The A, B, and C values determine the transformations, right? Um, Transformations, right? The simplest way I can put it, it basically determines if your parabola will go up, down, or sorry, let me redo it. Up slash down. Um, if it will look long, right? And what I mean by long is that it's gonna, instead of looking like this, how it should be, it's gonna look like this, and like more stretched out, you could say, or it'll look very wide, right? Depends. Right now, you're gonna stick to what's called a vertical, or yeah, just a vertical stretch or compression, and that basically is gonna determine if your quadratic or your parabola that you're graphing is skinny or wider, right? And we'll get more into depth about that, but today, again, focusing on just what a quadratic is and how it can be transformed and translated. Um, your parabola can also go left and right. And like I said, it can go up, up and down. It can look skinnier or wider. Again, I should make that in different colors. Give me a sec. Yes, so it can be skinnier or wider, and can go left or right and up and down. But the transformations we won't stick on to now, because right now the base graph y equals x squared has no transformations. And that's what we're going to deal with first, no transformations. Um, and yeah, that's basically it. Now, if we look at the key points of the parabola, well, it's not really, yeah, I guess key points, yeah. You have -2, -1, 0, 1, 2. You don't, for graphing, you don't need many points. You probably only need about 4 and 5, right? And just to show you guys the output value, the y value that you get. So when you input an x value, right? Um, for example, -2. That's like saying y, oh, let me change it. Y equals -2 squared. That's this right here. And then what is -2 squared? That is y equals 4. Because -2, my bad, -2 times -2 equals 4, right? And that's the same with all the other x values. -1 times -1 gives you +1, as we have in the output. 0 to the power of 2, anything that has a base of 0 and is raised to the power will just give you 0. As we can see, the output is 0, so that's right. Same with 1. 1 to the power of 2 is just 1 times 1, and 1 times 1 is just 1. And here, 2 to the power of 2 is just +4. 2 times 2 is 4. And you can do that with a range of coordinates. You just put in values and you see what the output is. And that's basically it. A quadratic, what makes it so distinct is that it's not like a linear, going like this, right? Um, it actually has restrictions on what the points can be, right? Your y value cannot be negative because, as we can see in the original graph, look at the lowest point here. Let me pick another color. Look at the lowest point right here that I'm circling in red. That point right there. Maybe I'll highlight it, it'll be better. Yeah, right here, that green point. That is called the vertex of your parabola, right? And the vertex is basically where the turning point is. That's the turning point, and it's your max or min value, the maximum or minimum value. So your vertex is your maximum or minimum value. Because in this case, it would be the parabola's minimum value since it is the lowest point, right? That is the lowest point and it cannot go further. You don't see the parabola stretching down here, right? It stops at 0, 0. That's the vertex or the origin, right? And that basically what makes a quadratic so distinct from a linear. It is raised to the power of 2. The base graph is y equals x squared compared to a linear, which is y equals x, basically. Um, and that's basically it. In the next video, you will learn um, more on the like x-intercepts and how to really graph parabolas uh, with transformations, right? With the parabolas going left, right, up, down, and if they have a vertical stretch or compression, right? And that's basically it. I hope you enjoyed this video. It was a little short. I mean, it's not that much to cover about what a quadratic is, right? Until you graph it, it'll make a little bit more sense. But that's basically it. It's raised to the power of 2, and base graph is y equals x squared. And oh, you might be wondering, oh, what are like these parts here? For oh, I just erased it. What are FD, SD? I don't know if you did anything in grade 9 regarding first differences, but it's essentially right here. This is a linear graph, right? And I took coordinates and I subtracted them together. So -2 minus -3, I did right here. -2 minus -3 gives me 1 right here, 1 right there. And same thing I do with 0 and -1. 0 minus -1 gives me 1 again. So basically, if the first differences are all the same, that means it's a linear. And for quadratic, there's things called second differences. So here, what you have to do is you calculate the first difference, right? You do 1 minus 4, 1 minus 0, 4 minus 1, right? And you calculate the first difference. So here we are left with -3, -1, 1, and 3. If we calculate the second difference, what we do is we take -3. It follows the same pattern. You take -3 and -1, and you subtract them again. What do you get? -1 minus -3, that gives you 2. Again, the second difference, 1 minus -1, that gives you 2 again. So therefore, all the second differences are the same. So what you can also conclude is that the second differences of parabolas will always be the same. And that's basically how, that's another way on checking how it's a quadratic. But really the ultimate way is just by seeing that it's raised to the power of 2. And that's basically all for quadratics. In the next video, we're going to talk about factoring quadratics, why we factor quadratics, how to graph quadratics in using vertex form, and that's basically it. So I hope you enjoyed today's video. I hope it helped you on understanding what a quadratic is. Again, we'll get into more of the A, B, and C values next video, but that's basically it. Again, subscribe to my channel, like, leave a comment for any feedback, and I hope you all have a great rest of your day, evening, or night. Bye, everyone.